Hey everybody, it's Dave from Clean Pro Supply, and we're going to talk about generators, power cords, and how they connect and integrate to maximize the use of the power from the generator to run the machines that you're using for the job site. The first thing I want to point out is the running watts are going to be different than the starting watts. So if you're not familiar with these two different numbers, you want to do the math so that the machines you're using are only fulfilling the running watts. The purpose of the starting watts, since that's a higher number, that's so that when you go to start up a vacuum or a pump or any other kind of motor, you're going to have a little bit of a power surge. So say for example, you're drawing 2,400 watts from a certain unit. Then as you turn that on, it may draw, say, 3,000 watts. I don't know if that's the exact number, but theoretically on that startup, it's going to do a little bit extra power surge to draw more power. So basically, if this generator is going to comfortably provide 12,000 running watts, as you do startups with the equipment you're using, it will handle up to a spike surge of 15,000 watts. Of course, as you're turning things on, you don't want to turn all your switches on all at once. You're going to turn one, and then another, and then another, and then turn them all separate, so that way it's kind of dispersed evenly. But when you're running your equipment, you can do all the math so that the equipment you're using is going to draw enough power to fulfill your 12,000 watts. You don't want to go over that because then you're going to start popping these breakers for the whole generator, but then also individually between the circuits. So we're going to talk about how you can use these cords, these splitters, and maximize the use of all the outlets on your generator, because say you have 4 power cords for whatever equipment you're using, you want to make sure you can draw enough power and then use all your outlets properly. So the way this is going to get marketed is different brands do it different ways. One may advertise this as a 12,000 watt generator, but another brand may advertise this as a 15,000 watt generator. So just do your homework before you buy a generator and make sure you know what you're looking at. Say they are advertising it as a 15,000 watt generator, check and see if that's a starting watt rating or if that's a running watt rating, because you're going to be focused primarily on the running watt rating. Don't worry about the starting watt rating. So if I have a vacuum, a hand grinder, a walk-behind grinder for maybe doing some concrete grinding, or maybe you have portable extractors for carpet cleaning, tile cleaning, pressure washing, whatever you're using, whatever equipment you have. So you have 4 circuits. They're each going to be drawing 120 volts, and then maybe they're 20 amps each. That means each power cord is going to draw 2,400 watts. So what does that mean? To get your wattage, the way the math works is you take your amps times your volts, and that equals your watts. So if I have 4 appliances, they're going to draw 120 volts each at 20 amps each. That's 2,400 watts each, which is, I think it's around 9,600 watts total. So that means I could probably add one more appliance at 2,400 watts. That'd be 5 different machines or 5 different tools or appliances, all drawing the same amount of power, would give me up to the 12,000 running watts. So how do I do that? Because I only have 2 circuits right here that are your standard plugs for a regular electrical cord. So if you're running 120 volt power cords and you have a cord end that looks like this, where you have 2 parallel spades and then you have a ground plug, these 2 parallel spades, the type of plug end this is, it's called a NEMA 15. Technically it's a 15 amp plug, but you may have another type of plug where instead of having 2 parallel spades here, you have one that's parallel this way and then another one that's perpendicular, kind of like this. That's technically a 20 amp plug end called a NEMA 20. So you can see on this, the female end here of this adapter, there's the ground receptacle there. You have the spade going this way, and then here it's actually a T-shape. That T-shape allows you to plug in either a NEMA 15 like this, or a NEMA 20 where the other spade is going this way rather than this way. Same thing on these generators. These are all NEMA 20 outlets. So it'll take either a 15 or a 20 amp plug end, whichever you have, it's going to fit. Commercial code for commercial outlets, same way. If you're in a commercial building, it should all have these female receptacles that will allow a 15 amp or a 20 amp plug to fit into that. If it's a residential setting and it's only a 15 amp outlet, it's only going to have the 2 parallel female receptacles, so you're not going to be able to plug in a 20 amp plug to that. However, if you know that it is a 20 amp circuit, or you have to hook up maybe a NEMA 20 plug into a NEMA 15 amp plug, then you can use this adapter, and that basically takes your male 15 amp to your female 20 amp. And then that way, if you have a vacuum that has a NEMA 20 on it, you can convert it down to a NEMA 15. and then you can plug that into a residential setting. So for example, maybe that vacuum is only drawing 14 amps. Well, there's no problem hooking that into a 15 amp circuit because it's only drawing 14 amps. So you can use this adapter to get to the right proper plug. Aside from that, you have 4 plugs total here, but I like to see this as 2 circuits because each circuit is allowing 120 volts times 20 amps. If you plug one thing here and then one thing here and you turn them both on, you're either gonna pop the GFCI pre-breaker here, or you're gonna pop whichever breaker, it's these up above, you're gonna pop these breakers because this is just one circuit and then this is one circuit. So what I would recommend is you're gonna plug one plug into here and then you're gonna plug another plug into here. But then the question is, okay, I've got 3 more plugs because I've got 3 more circuits that I need to plug into. How do I do that? Do not plug them in here, just keep one here, and then you can start utilizing these others. So this one here, this is actually 120 volts, but it's a 30 amp instead of a 20 amp. So if you have an adapter that goes from a NEMA 20 to, I'm assuming this is probably a NEMA 30, then you can do that and plug right into here, or don't worry about that. And then you can take an adapter like this. It's actually got 4 male prongs. That will plug into here. And now that's going to split you down to 2 more 120 volt females, and you can plug in 2 more cords here. The only thing to keep in mind is this is still a 30 amp circuit, and even though it's a 220 volt circuit at 30 amps, you still have to stay below 30 amps combined here. So you would theoretically want to keep 2 15 amp circuits, or 120 and 110. You don't want to exceed 30 amps total. So you can either use one, if you only 1, 2, and then maybe 3, or if you want to use both of these, then just make sure that whatever power is coming out of here does not exceed 30 amps. The other option you have is to take a 50 amp plug like this. This is a similar type of splitter, but that's going to go into this 240 volt 50 amp plug like that. And now again, you've got 2 more. Now the benefit to this adapter is now you have 50 amps to play with. So you can go 20 and 20, or I would not recommend it, but you could go 20 and 30, but I don't think there's a plug that would even be 30. But this way you basically have 2 20 amp plugs. Here you have 2 20 amp plugs. So that's 2, 3, 4, and then either a 5th. And that, if you're drawing 20 amps from all 5 of these, that's gonna maximize your 12,000 watts. Again, because you have 2, 3, 4, 5 circuits times 120 volts times 20 amps equals 12,000 watts. So hopefully that math makes sense to you. But this way, if you're running, say you're doing concrete grinding, maybe you have a hand grinder, a multi-tool, 2 vacuums, and then a work light. That gives you 5 circuits that you can use up to your 12,000 watts. Anything over 10,000 watts, make sure it has a 50 amp socket. Because if you don't have this 50 amp socket, even though you may have 10 or 12,000 watts available that the generator can create, if you don't have the proper plugs, there's no way you're going to be able to utilize all of that power properly and disperse it amongst enough 120 volt circuits with the power cords that you're using. So just to recap a little bit, you have volts times amps equals watts, and that's how you can measure your running watt capacity of your generator. This outlet, even though there's 2 plugs or 2 sockets, only use 1 because this is 1 circuit and you don't want to pop the circuit. So 1, 2, this is 120 volt with a 3-prong 30 amp. You can use that if you have the proper adapter, but you only use this for 1 appliance. This is 120 or a 240 volt. So if you use this plug here, you can split this 240 volt into 2 single 120 volts. And then you have a 240 volt 50 amp, and you can split that also into 2 power cords here. So if you have any questions anytime about any of these, of course, just comment on this video and I can respond to your comment, or send me a private message and I can respond that way as well, or email sales@cleanprosupply.com, and I'm happy to assist with any questions you have about generators. I hope you guys all have a good day and hope this helped. Take care.